We now talk about convolution of two Poisson random variables, say x and y. So x is distributed with parameter lambda 1 and y is distributed with parameter lambda 2. Both are Poisson random variables. So probability that x plus y is n is probability that x is k times probability that y is n minus k. So you add these two, you get n. So x is distributed with parameter lambda 1. So you have probability that x is k is given as exponential of minus lambda 1 times lambda 1 to the power of k divided by k factorial. Probability that y is n minus k, this is given as exponential to the power of minus lambda 2 times lambda 2 to the power of n minus k divided by n minus k factorial. Now if you multiply these two, you get exponential of minus lambda 1 minus lambda 2. And then if you sum up lambda 1 k over k factorial times lambda 2 to the power of n minus k over n minus k factorial, you get lambda 1 plus lambda 2 to the power of n divided by n factorial. So this will come from the binomial expansion. So that is using the summation. So you can check this by using binomial expansion, but this is the result you get after summing everything up. So you can say x plus y has a Poisson distribution with parameters lambda 1 plus lambda 2. So you have exponential of minus lambda 1 plus lambda 2 times lambda 1 plus lambda 2 to the power of n divided by n factorial for x plus y is equal to n, and therefore you say this is the parameter. Similarly for x, you had the parameter minus lambda 1 times lambda 1 to the power of k divided by k factorial. Now we talk about convolution of normal random variable. So this is an important result and it is used at large number of places. We are not going to prove this result in detail, but it is important to remember it. So say you have independent random variables x1, x2, x3, x4, xn, and all of them are normally distributed with parameters. Each of these random variables is normally distributed with mean mu I and variance sigma I square. So then if you take the sum of these random variables, they are normally distributed with mean as summation of all these mu i's and variance as summation of all the variances of individual variables. So this is the mean and this is the variance. So for example, if x1 is distributed, say it is normally distributed with mean minus 1 and variance root 2, and x2 is normally distributed with mean root 3 and variance 1, then x1 plus x2, this is normally distributed with mean minus 1 plus root 3 and variance as root 2 plus 1. So this is important to understand. So, and this result is used very often, and that is why normally distributed random variables are so important, because it is easy to take their sum and then come up with a new normal distribution which will have the mean as the sum of the means of individual normally distributed random variables, and the variance is also sum of the individual variances of the normally distributed random variables. So this makes our life very easy.